In this video, I'll be trying to explain Thevenin's theorem, more commonly known as Thevenin's equivalent circuit, and generally how we can implement it. Basically, it is the simplification of a circuit to a simpler version by converting any complexity of a circuit to having just a single voltage source and a series resistance connected to a load. It follows the same definition of linear that is found in superposition theorem, where all equations must not have any exponents or roots. The criteria is quite simple. Passive components are required, which consist of resistors, inductors, and capacitors, where Thevenin's theorem can be applied effectively, while other nonlinear components, such as semiconductor components, cannot be used, as their opposition to current changes with voltage and/or current are quite different. I'm going to jump into an example, try and explain. So let's suppose that we decide to designate R2 as the load. We already have four methods of analysis, but we will be using superposition theorem, determining the voltage across R2 and current through R2. Imagine repeating any of these methods over and over again to find out what would happen if the load resistance changed. Thevenin's theorem makes this easy by temporarily removing the load resistance from the original circuit and reducing what's left to an equivalent circuit composed of a single voltage source and series resistance, as I have mentioned before, and this is what is known as a Thevenin equivalent circuit. This is the circuit, and it is the equivalent of all the components that we have seen before. If correctly derived, it will behave exactly the same as the original circuit formed by the other components. The load resistor, voltage, and current should be exactly the same for the same value of load resistance in the two circuits. The advantage in performing the Thevenin conversion to a simpler circuit is basically that it makes load voltage and load current so much easier to solve than in the original network. When I go back to the much simpler look of the circuit, and like I'm trying to suggest that it's not magic, it is the correct application of the Thevenin circuit. The voltage between the 2 points where the load resistor used to be attached is determined. Now we can use any analysis methods at our disposal, and they should be giving you the same answers that we can have found in the same complex circuit that we had previously seen. And thank you for watching the video. I hope I could have explained it in the best of my capabilities. Thank you for watching.